Greetings, dear friends. We are going to see the second video examples related to new 7 tools on relations diagram. We have already seen a full module of 7 new tools dealing with all the tools separately. But now we are going to see each tool individually with one example deeply. So, in that way, let us understand new 7 tools deeply through examples. Again, as explained, each tool is explained again with one example in separate videos. Let us recall our learning on relations diagram. Relation diagram clarifies intertwined causal relationship in complex problems or situations to find appropriate solutions. In other words, the causes are complex and cause and effect are really complex, and there is a relationship between one cause to several causes or several causes related to one cause and one cause related to several effects, like that. Such is the situation. In such situation we will be using relations diagram. So relationship diagram method is used to search for the causes of a defect. So we will use it why the causes are happening, or we will use it for clarifying the structure of a problem. To understand deeply about the problem itself, we may use relations diagram, or sometimes to deploy suitable means to achieve an objective. That is, when we want to achieve an objective, where all we have to concentrate. So, in such a situation, also we will be using relations diagram. In such a situation, there should be complicated causes and effects. So, such is a situation we will be using relations diagram. And we will use whenever there is a complicated yet wind relationship between cause and effect or objective and means. So, these are all the situations where we will be using relations diagram. So, how are we going to identify the relations diagram? The relationship diagram employs arrows to show cause and effect relationship. So there will be causes and effects put in the form of a circle or a ellipse, and we will be connecting with arrows. So the relationship diagram implies arrows to show the cause and effect relationships among a number of problems and factors that influence them. Let us understand relationship diagram deeply with an example. So let us see the background of the example. An organization which is a leading tier 1 company. So that company, tier 1 company, supplies components to an original equipment manufacturing company of passenger vehicles. So the tier 1 company supplies to a passenger vehicle OEM, and that tier 1 company wanted to reduce the assembly rework of the products. So whatever products they make, they want to reduce the assembly rework or eliminate the assembly rework. So for that purpose, the company formed a cross-functional team, CFT, to identify various causes and arrive at improvement initiatives which can become the drivers. So the improvement initiatives will become the drivers. So they will be leading to substantial reduction or elimination of rework. How? Through a relations diagram. Let us create a relations diagram. We need a purpose statement. The leader of the team, who is the leader of the team, head of quality assurance, he prepares the purpose statement and explains to the CFT members. So the team starts brainstorming session with the purpose statement, which is created by the CFT leader, identification of various factors for product malfunction. So the team is brainstorming. The team members started brainstorming session with the purpose statement, which is nothing but identification of various factors for product malfunction. And CFT members identify various factors. The factors may be a cause or an effect. The members then write the factors and draw ellipses or circles around them. So, in order to separate one effect from the other or one effect from the cause, they encircle the written factors into elliptical shape or circles. And arrows are drawn between causes to effects. So they connect using the arrows, the causes and effects. Similarly, one Cause can be connecting multiple causes or from one cause to another or many causes. That's how they did and they created the relations diagram. So this is the relations diagram. So this is the relation diagram with various factors generated by the CFT team members. So you see the causes or factors or effects are written and then they are circled by ellipses. All the factors written inside elliptical shaped boxes. Arrows connect one cause to another or multiple causes as applicable. For example, inadequate parts design. This may be due to faulty design calculations, improper material selection, no reference to design rules, design guidelines, incomplete design FMEA, incorrect application of geometric dimensioning and tolerancing principles. So all these things lead to inadequate parts design. Similarly, inadequate design verification. So this is related to inadequate application of simulation tools such as finite element analysis, lack of test facilities, lack of test standards. Similarly, weak quality control system. So that is coming because of absence of process or the product audit, inadequate SOP and work instruction, absence of POK, weak measurement system, like that. Similarly, no reference to process design rules or process design guidelines. So that is caused by process design rules, process design guidelines not standardized. Improper process design, that may be due to incomplete process FMEA, weak process calibration systems, weak measurement system calibration system leads to weak measurement system, absence of POK, inadequate SOP and work instruction, that leads to weak quality control system. So various causes are separately written and they are circled by ellipses, and arrows are drawn between cause to another cause, one cause to multiple causes, or between cause to effect. And we are also seeing numbers. So what is the number indicate in each of the ellipse? Numbers inside the boxes indicate number of arrows in and a number of arrows out. For example, in this case, inadequate parts design, 7, 1 means there are 7 inward arrows. So there is one inward arrow, then is another inward arrow, third, fourth, fifth, sixth, seventh. So 7 inward arrows and only one outward arrow. Similarly, product malfunction. There are 1, 2, 3, 4 inward arrows, 1 arrow out. So we see several arrows in, several arrows going out. So how do we find out the drivers? Let us see in the next slide. So in this slide, what we capture is how many arrows are coming inside, how many arrows are going out. So the number of arrows going out, if they are maximum, they are the drivers. Here, inadequate design verification, 4 are inside, 2 are going out. Similarly, weak quality control system, 4 are coming inside, 2 are going out. Compared to inadequate parts design, 7 are coming in and only 1 is going out. So here, improper process design, 4 are coming in, only 1 is going out. So the net arrows. So here, number of arrows going out minus number of arrows coming in, 2 minus 4 is minus 2. Here also, number of arrows going out, number of arrows coming in, 4. So 1 minus 4 minus 3. Whereas here, number of arrows coming in are more. Number of arrows going out is only 1. 1 minus 7 minus 6. Okay. So here 1 minus 4 minus 3. Here number of arrows going out is more, 2, and number of arrows coming in are 4. So 2 minus 4 minus 2. So obviously the number of arrows going out, net number of arrows going out is more in these two. So they are called drivers. So driver 1 is inadequate design verification and validation that leads to the outcome of inadequate parts design. Similarly, weak quality control system, that is the driver which is leading to improper process design. Okay, so these are all the drivers and these are all the outcomes. So by using this relations diagram, the organization come with various initiatives. So how are we going to interpret the relations diagram? Outcome 1 is inadequate parts design. In order to address this, 7 causes have to be addressed. Okay, 7 causes have to be addressed. Outcome 2 is inadequate process design. In order to address this, 4 causes have to be addressed. Okay. Driver 1 is inadequate design verification validation. To improve this, 4 causes have to be addressed. And driver 2 is weak quality control system. To improve this, 4 causes have to be addressed. So this is how we use the relationship diagram. By making the relationship diagram, we are able to capture or understand the problem very clearly, why our product malfunction is happening, and how can we control this, or how can we eliminate that complaint. So finally, the relation diagram clarifies intertwined causal relationship in these complex problems or situations to find appropriate solutions. By addressing drivers, inadequate design verification and validation, and weak quality control system, product design and process design can be improved to eliminate customer complaints. Thank you for your active participation. We will see another tool in the next video.